This is the explainer corresponding to the topic of causality. First, I'm going to provide guiding questions and then my answers. But if you can, after I provide the questions, try to answer the questions on your own or with classmates, the way you want to do it, and then come back and see whether your answers match the ones I provide in this explainer. Okay, so let's start with the guiding questions. Question 1. Explain the 4 causes of Aristotle and give examples. Question 2. What is the difference between the mechanical conception of causality and that of Newton? Question 3. What are the 2 components of Hume's conception of causality? Question 4. What is a sufficient condition for an effect to occur? Question 5. What is a necessary condition for an effect to occur? Question 6. Why David Lewis proposes to take into account only the second part of Hume's definition of causality. Question 7. What each rag of Pearl's ladder of causation tell us about causality? Question 8. What is a chain and why is it important? Question 9. What is a common cause and why is it important? Question 10. What is a collider and why is it important? Okay, try to answer those questions and then come back for the answers. Okay, answers. Question 1. Explain the 4 causes of Aristotle and give examples. Okay, so remember 4 causes of Aristotle are the material cause, the formal cause, the efficient cause, and the final cause. The example provided in the masterclass is that of a painting. The material cause is what constitutes the object or the event. In this case, it is the canvas and the ink or the paint. So that's the material cause. The efficient cause is what produced that, what other event or other object or other person produced that. So in this case is the painter and the movements of the brush and the paint on the canvas. So that's the efficient cause. The formal cause is the form in the painting. So it was a landscape in that case. So that's the form. And then the final cause in this case is the idea of the painter of what she wanted to express in the canvas. So let's take another example, a more difficult one for Aristotle, which is how do we explain that an apple goes to the ground? Newton explained this with gravity, but how does Aristotle explain this with the 4 causes? Well, the material cause. The material cause is the apple and the earth, so the apple falling to the earth. That's what constitutes the event. The formal cause is the trajectory of the movement of the apple. The efficient cause is perhaps someone with scissors cut the apple from the tree and that's why it fell, or the wind produced that movement. So that's the efficient cause. Now, what's the final cause? Because it's easy to determine a final cause when there is a person producing that. But in this case, well, the final cause has to do with Aristotle's view of the universe, which is that earthy objects tend to go to earth, watery objects tend to go to water, gases tend to go to the air, so above, and heat even higher than gases. So objects have a purpose and they tend to go to where they belong, and objects tend to go to earth. So that's why the apple falls to the ground. Okay, so try to think of examples. It's never easy to do this because this theory of causality is not a very good one at this moment. So sometimes you have to provide examples that are a bit awkward. So, but try to think about it and try to provide examples in the way I did. Okay, question 2. What is the difference between the mechanical conception of causality and that of Newton? Okay, so here we have Descartes as an example of the mechanical conception of causality and Newton. So remember that for the mechanical or the mechanists, philosophers, every movement of an object is caused by the movement of another object, and this before by another object, and like this. So the universe is like a mechanical clock in which objects need to touch in order to produce a movement in another object. And if some object is moving, that's the cause is the laws of nature that are producing this movement. Newton differs in two ways. First, gravity in Newton, it's a force at a distance, so there is no contact between objects. The gravity is not just the apple falling to the ground, but it is what governs the movement of planets and the moon going around the Earth. So what is these objects are not touching. So this is a difference. But the other difference is that Newton used the word cause to when we have a very clear effect of one object onto another. But let's say that an object, a particle, has been moving since the Big Bang. Of course, when Newton and Descartes were talking about these things, the theory of the Big Bang was not developed. But let's say one particle has been moving from the Big Bang. Newton wouldn't consider that this movement of this particle is caused. That is the normal state of affairs of that particle. It's moving. It's been moving forever. He only talks about cause when that particle is affected by another object that produces a movement. Question 3. What are the two components of Hume's conception of causality? Okay, this is quite easy. We've got the definition of Hume in Inquiry Concerning Human Understanding. He said, we may define a cause to be an object followed by another, and where all objects similar to the first are followed by objects similar to the second. So that's the first conception of causality. We've got an object followed by another, and objects of the same category followed by objects of the same category of the second case. So that's the fact that an object or an event follows another is one important aspect of causality. Now, this definition, the first one, it was the only one in a book he wrote about 10 years earlier. But for some reason, he found that he had to add the second component. And he says, or in other words, if the first had not been, the second never had existed. He had to add what is now called the counterfactual. So he says that something is a cause. If that had not occurred, then you wouldn't see the effect. So these are the two components of Hume's conception of causality. First, that one object follows another, so it's the constant contiguity between two objects, temporal contiguity, first the cause, then the effect, but also it happens many times. And the second one is the counterfactual component. Okay, question 4. What is a sufficient condition for an effect to occur? And question 5 is what is a necessary condition? So we are going to answer those questions. So, sufficient condition. Sufficient condition is sufficient if that condition occurs. That means the effect will occur. Now, this may be a necessary condition or not. So, sufficient is that if that condition occurs, the effect will occur. But it may be necessary or not. What does it mean? It means that there may be other conditions that may produce the effect as well. So if it is a sufficient condition, it means that with this condition, you will see the effect. But it may be other conditions that will produce the effect as well. So this is about John Stuart Mill, and John Stuart Mill says, well, sufficient condition is not a cause, because it could be you've got this sufficient condition that produces the effect, but there may be other conditions that produce the effect as well. So that something is sufficient is not enough. So what the other component is, what is a necessary condition for an effect to occur? So a necessary condition, if and only if that condition occurs, the effect will occur. So you need that condition for the effect to occur. If that condition does not occur, the effect will not occur either. So necessary condition, it's that you need that condition for the effect to occur. Without that condition, the effect will not occur. So also we say that it may be sufficient or not. A necessary condition may be a sufficient condition or not. It means that if that condition produces the effect and no other conditions are necessary, then it's also a sufficient condition. So it's necessary because without that the effect doesn't occur, but in this case will be sufficient because we don't need anything else to occur. Conditions could be necessary but not sufficient. So a condition that is necessary but not sufficient is that something that needs to occur for observing the effect, but it's not sufficient. We need something else to occur as well to observe the effect. So then we come to the conditions that are both necessary and sufficient. So conditions, or a condition could be one or more that are necessary and sufficient. They have to occur for the effect to occur, and no other conditions will make the effect to occur. So necessary, so the first part, they have to occur for the effect to occur, that's the necessary part. And no other conditions will make the effect to occur, that's the sufficient part. So that's what John Stuart Mill calls the cause, something that is necessary and sufficient for the effect to occur. Okay, let's go to the next question. Question 6. Why David Lewis proposes to take into account only the second part of Hume's definition of causality. Okay, there are two things that he claims. One is there are situations in which the first rule occurs and there is no causality. So, for example, night follows the day, and that's it has this situation can be an example of the first component of Hume's definition of causality, but day is not the cause of the night. Yeah, there is this constant conjunction, always night follows the day, but that doesn't mean that the day is the cause of the night. So that's why one of the reasons why David Lewis proposed to eliminate the first part. And the other important reason is that sometimes the connection between cause and effect may not happen repeatedly. So, for example, a person shoots and kills another person. That happens. The shooting is the cause of the other person to die, but that's not something that occurs repeatedly. It occurs one time, and that's perfectly okay to call that a cause, even though it doesn't happen repeatedly. So that's why David Lewis put emphasis in the counterfactual aspect of David Hume's definition, and to get rid of the other aspect of constant conjunction between cause and effect. Okay, question 7. What each rag of pearls ladder of causation tell us about causality? Okay, so remember that Judea Pearl proposed this ladder of causation in which we've got observation as the first rag, action as the second, and imagination as the third. And he claimed that in each rag of causation we can produce different types of knowledge. So in observation we can only establish correlation. So if we observe the values of variables as they occur without doing any intervention, then we can only establish that two variables are correlated. And that could be very important to know that two variables are correlated. In fact, it is very important, but we cannot establish causation. So, because the fact that two variables are correlated, it could mean that variable A causes variable B, that variable B causes variable A, so it could be either way, and we don't have, by observing only, we don't have the tools to determine which causes which. But importantly, there may be even a different reason, which is that there is a third variable that causes both A and B, and that variable is unknown to us, and therefore we cannot establish a causal relationship between variables A and B. So by observation we can only establish correlation, but not causation. And he is very critical with the statistics community, that statistic community settle on the idea that you can only establish correlation, you can make predictions, but you can never establish causation. But he proposed, and remember the story I told about the conversations I had with the causality demon. And the causality demon says, well, I was forgotten because for a while causality was disappeared from the vocabulary of science and mainly statistics. But with Judea Pearl, the idea of causation, not only Judea Pearl, others as well, but the idea of causation revived, and now it's currently scientists and statisticians as well are trying to talk about causation. So second ladder of the ladder, second rag of the ladder of causation is action. And this is very important because this is to me the key of Judea Pearl's conception of causality. It is an intervention conception of causality. How can we determine whether one variable causes another? Well, the only way we can do it is by making an intervention in one variable and observe the effect on the other variable. excuse me. So we make an intervention by, for example, if the variables we are interested in is whether a medication reduces anxiety. Medication is one variable, anxiety is the other one. So we make an intervention, so we apply the medication to some people, and we observe the effect. And if by producing the intervention we observe an effect, or for example reduction of anxiety, then we can say that medication caused that reduction of causality. Now, intervention in itself is not enough. You need to consider the third rug, which is imagination. There are two aspects of this imagination. First, as a complementing what we are doing in the action level, we need to imagine what would happen if we don't do the intervention. And that is what creates the necessity of having a control group in the studies to understand causality. So if we apply medication when we observe a reduction in anxiety in a group of people, it may be the case that the reduction is not due to the medication, but is due to the pass of time. So we need a control group in which we don't give the medication and we observe the effect. So if there is a difference in the effect of the experimental group in which we applied the medication versus the group that we didn't apply the medication, then we can determine that the medication caused the reduction in anxiety. So we need to use our imagination, and by using our imagination, we produce an intervention that is to a group and no intervention to another group, which would be the control group. But there is another component of imagination that is very interesting in Judea Pearl's conception of causality. And more than the conception of causality, the tool he proposes to use to understand causality, which is the causal models in the form of DAGs, which are directed acyclical graphs. These directed acyclical graphs are a mathematical structure which have a very nice representation, a graphical representation, and it's very easy with these edges and nodes. But there are mathematical formulas behind that, and by using theorems that we are not going to see in this unit, he proves that sometimes you can establish that there is causality without doing intervention. So we are not going to go through in this unit, but that's an interesting aspect of Judea Pearl's concept of imagination. Okay, so now we move to question 8. What is a chain and why is it important? Okay, so this is a chain. A chain has at least three variables, and first variable, in this case x, causes v, and v causes y. And why is it important? Let's consider that x and y are variables that we know very well, and that means that we can measure very well, and we tend to find an effect. So basically by producing an intervention in x, we get an effect on y. But sometimes we want to know a bit more. We want to know whether that effect on x on y can be explained by another variable. Perhaps that variable is not as easily measured, but with With clever experiments, we may be able to measure, but they're not variables as easy to measure as x and y. But let's say sometimes we measure, maybe more expensive to measure that variable, and so we don't do it usually. So an issue that is very important in statistics and in epidemiology and in many sciences is whether there is a mediating variable. And what we can do is to determine whether this mediation is total or partial. For example, here we want to know whether the effect of x on y is mediated by v. So let's say x causes v and v causes y, and that's fully mediated effect. That means that the effect of x on y is because x produces a change in v, and that change in v produces a change in y. There is no direct connection between x and y. But we can find that is not fully mediated. So in this case, if we can say that the effect of x on y is partially mediated by v, in that case, we need to add an arrow between x and y. Okay, so v can fully mediate or partially mediate the effects of x on y, and then if partially mediates, then we need an arrow that goes from x to y directly. Okay, so that's the chain. Question 9. What is a common cause and why is it important? So here a common cause of x and y is u. So we are interested in x causing y. What's the relationship between x and y? But u is a common cause of x and y. Why? Because it causes x and it causes y. That is reflected in these two arrows. Well, why is it important to understand a common cause or the existence of a common cause? Because a common cause is a confounding variable. So if we are interested to know whether by changing x we change y, and sometimes, let's say we've got observational data only. We've got variable x and variable y, and we observe a strong correlation between x and y. But as I mentioned before, we need to consider that there might be a common cause, which is sometimes an unknown variable that causes both x and y. And therefore, we cannot establish that there is causality. If we don't have a way of ruling out the possibility of doing that. So if we don't have the possibility of ruling out the existence of a confounding variable, then we have two options to control for the confounding. One is to run an experiment in which we fix the value of x and we observe the effect on y, and we have two groups. So we have value of x at some level and value of x at another level, and we observe the effect of y. By that, when we fix ourselves, the experimenter fixes the value of x, then is blocking this pathway between u and x. And therefore, we can say that the effect of x on y is because of x and not because u caused x. And the other way is that if we know the variable that is confounding, sometimes the confounding variable could be gender or could be age. So that means that the effect of X on Y is different in different genders or is different at different age levels. So what we need to do is to control for U. And so what do? We measure the effect of X on Y at one level of U, and then we measure the effect of X on Y at another level of U, and by this way we can establish the causal relationship between X and Y and the strength of the effect of the relationship between X and Y. Okay, last question. What is a collider and why is it important? So in this case, the collider is Z. Collider is a variable that receives two arrows, at least two arrows. So Z is receives the causal relationship between Y and Z, and also X causes Z. So Z receives two arrows. So it's a common effect. It's an effect of Y and it's an effect of X. Again, so we are interested in the effect of X on Y, but we know that Y affects Z and X affects Z as well. So that it can happen in these cases is what we call selection bias. That's why it's important. So there is a tendency of statisticians and scientists to, if we know, if we can measure variables, we measure as many variables as we can, and we control for as many variables as we can. So I'm interested in the effect of X on Y. But I can measure in many other variables in the same group of people. And then the idea is we measure all of them and we control for all of them, so we have a clean effect of X on Y. But that's wrong. And we wouldn't know this if we didn't have these causal models. That's an important point by Jude Appel. So in the case of if Z were a common cause of X and Y, then we need to control for Z. That's what I explained previously. But if Z is a common effect of X and Y, if we control, we introduce a selection bias. So, for example, if you want to measure the effect of practice on the acquisition of a skill, you will have a strong effect. The more you practice, the more skillful you become. Now, let's say Z is the ranking you acquire in this in the sport in which you are acquiring that skill. So controlling for Z would be to measure the effect of X on Y at different levels of that ranking. So let's say we study the effects of practice on skill on the top players in a sport. Well, that dilutes the effect of X on Y because you restricted the range of skill and the range of practice, and then you may not find an effect at all. While if you use all the participants, not just the ones that are at a specific level, then the effect of X on Y will be found. So in this case, when we know that something is a common effect of X and Y, and we are interested in the relationship between X and Y, the causal relationship, we should not control for that. And that's one of the most important aspects of using causal models as proposed by Jude Appel.